Hi everyone and welcome to the new video. This video was inspired by the channel Electron Impressions and their video about particle accelerator versus plant. It was an interesting experiment and I will not spoil the results, you should watch it on your own. But obviously the particle accelerator is a very expensive thing, and after watching that I wondered, can we do the same experiment with a much lower budget and with different types of radiation? And indeed we can, and in this video I will show you how. But before we begin, an important warning: ionizing radiation can be dangerous. Don't do this at home unless you fully understand the risks. And now let's get into it. The general idea of the experiment is easy. I bought 3 identical plants in the supermarket and I will exposure them to the different types of radiation. And before we begin, I will explain what kind of radiation we have. In general, there are 3 types of radiation: alpha, beta and gamma. A radiation detector can show you only one value, but practically they are completely different. And now I will show you all 3 of them. My first test source is an americium smoke detector. It is mostly the source of the alpha radiation. Alpha particles are heavy helium nuclei. They consist of 2 protons and 2 neutrons. These particles have a lot of energy but very small penetrating power, and they can be even stopped by a piece of paper. And I will show now how it looks. And here I have a radiation detector with a Pancake style probe. It is sensitive to alpha and we can see the radiation is high. But I can put a sheet of paper and we can see that it is much lower. Now we can also understand why most of the budget radiation detectors cannot detect alpha. Because it is just not going through the plastic case. You need a detector with a special thin window. But anyway, as we can see, the penetrating power is low. And I will not use the alpha source for the plant because it is useless. Alpha radiation cannot penetrate the plant. So the first plant will be lucky and it will be in the control group without any radiation exposure. But still, if you want to see the results for alpha, write in the comments below and maybe I will make a second video. And now let's see how the beta radiation works. Beta radiation is different. It's a stream of high speed and high energy electrons. And as a source of beta radiation, I will be using this Fiestaware style jar. I ordered it in the US and I also have 2 similar jars made in Europe. Beta radiation has more penetrative power. It can easily go through the paper, but it can be blocked by the piece of the aluminum. Let's see how it works. And as we can see, I covered the jar with the aluminum sheet. And practically there is no radiation anymore. As I remember in the video of the Electron Impressions channel, their particle accelerator was emitting beta radiation, but in my test I will also use a gamma source. As the source of the gamma radiation, I will use several vintage objects with the radium paint. Radium was discovered in the beginning of the 20th century, and it was shortly found that the mix of radium and zinc oxide can glow in the dark, which was cool at the time. And this is the most radioactive object I have. It's the Martian compass from World War I, made in the US. It was made at the time when the danger of the radiation was not clear yet, and as you can see it's pretty radioactive. If I hold this compass in the hand for 5 minutes, I can get an equivalent dose of 1 arm X-ray, so it's not dangerous to hold it for the short time, but it's hard to imagine what could happen to a soldier who was carrying it all the day on his chest. And as a second object I will use this jazz watch made in France, maybe in the 30s or 40s. It's not so radioactive as a compass, but it's still spicy enough. I will discuss the radiation safety a bit later in this video, stay tuned. By the way, these radium dials are not glowing anymore. The radium is still radioactive, its half-life is about 1400 years. But the lume is depleted, so it's not glowing. Still we can see the glow with the ultraviolet light, so we can see how it was looking originally. It's interesting to see. And I will place all 3 objects around the second plant, so it will be exposed to the gamma radiation. And now let's begin the experiment. I am surrounding the first plant with the gamma sources. As we can see, it is a compass and 2 vintage clocks. As far as I understand, in English it's called clock and not a watch, right? Correct me in the comments if I'm wrong. So the first yellow plant will be exposed to the gamma radiation provided by radium. As we can see, the higher radiation is detectable near the plant, but I will make more detailed measurements later. And the next plant will be exposed to the beta radiation provided by the uranium glaze. I have 3 jars which I will place around the plant. And the third plant, as I mentioned before, will be used as a control group. It will not be exposed to any radiation. And this is how all these 3 plants look before the experiment. And let's begin. I will water these plants a bit, and the first checkpoint will be 1 week later. Okay, 1 week later I can review the plant's health. As we can see on the screen, the plant was staying for the whole week surrounded by 4 radioactive objects. Let's see what's going on. But first I will try to analyze how much radiation did the plant get. And technically it is not so easy to do. First, because we have 2 types of radiation, beta and gamma. And second, because different radiation detectors have different calibration values. And here is the first plant. It was exposed to the gamma radiation from a radium paint. And here is my radio code scintillation detector. And we can see the place where the plant was located. And as we can see, the radiation level is approximately 100 times more than a background. And the second detector is a Geiger counter with a Pancake style probe. It is sensitive to gamma and beta, and the radio code is not sensitive to beta. And as we can see, its values are 3 times higher than on the radio code. However, this GMC is not energy compensated, so getting the exact amount is a bit of a puzzle. I think as a generic estimate I can tell that the radiation level is about 150 times more than a background. I know that it is not very accurate, so if you have a better estimate feel free to write in the comments below, but for our task it is good enough. Anyway, 150 times more than a background sounds high, and I will explain the safety a bit later, but let's first check the second plant. Here we have the uranium glaze, which is mostly the beta source. And as we can see, the radio code detector is not very sensitive to beta, so we can see a much lower number on the screen. A Geiger counter with a Pancake detector is sensitive to beta, and it shows the value of about 100 times more than the background. I don't have another third detector to validate these values, so I will use this value as a generic estimate. Again, if you have a better idea, write in the comments below, and if your calculations are interesting, I can add them to the video description. Anyway, I don't want this video to be too technical, so how big is this amount in the common sense values? You can see a calculation on the screen. As we can see, the first plant is getting 18 microsieverts per hour, and the second plant is getting 12 microsieverts per hour. As an example, an X-ray chest is about 100 microsieverts, so I can roughly estimate that the first plant is getting the dose of 4.3 chest X-rays per day. And the second plant is getting lower dose, it's about 2.8 chest X-rays per day. Obviously the plant has no chest, but is this experiment safe for us humans? Let's talk a bit about safety. Obviously I am not a government authority, so please don't treat my message as a legal advice, and if you want to do the same experiment, do it on your own risk. But I can explain the general idea, and here on the screen we can see an official statement from the United States Environmental Protection Agency, and we can see on the screen that radioactive antiques are usually not a health risk if they are in the good condition. And generally the logic here is simple. The high radiation is only on the surface. There is a well-known inverse square law. If we increase the distance 2 times, the radiation decreases 4 times. In the case of the watch with the radium dial, the radiation can be relatively high on the surface, but already within 10 centimeters it can be barely detectable, and within 20 centimeters it can be not detectable at all. So personally I would not keep this watch near my bed, but it is safe to keep it in the cabinet. And again, don't treat my message as a legal advice. If you have some radioactive antiques, take a radiation detector and make your own measurements. So as we can see, the radiation danger is practically low. but another possible threat can be in the radon gas. A radium dial can emit a bit of radon. Radon is a radioactive gas, and it can be emitted in the small amounts by the radium paint. However, it is also emitted naturally by the soil. So if you never had any radioactive objects at home, you can still have a high concentration of radon. It is a bit off topic for this video, but I can show my radon detector, and as you can see the value is low, so there is no risk here. And now let's return to the experiment and see how it's going with the plants. And as we can see on the screen, both plants are fine. I don't see any problems with them. There was even a funny effect. The plant that was not exposed to the radiation is actually the smallest one. I was wondering why it is so, but I watched the original footage, and this plant was initially a bit smaller, so maybe it is just a coincidence. However, there is a theory of the radiation hormesis, and this theory tells us that a small amount of radiation can stimulate the plant growth. But I'm not a biologist, so I cannot tell if it's true or not. Still, it is interesting to see that the plant that was exposed to beta for now is the largest one, but maybe it's just a coincidence, maybe it's a bit different lighting conditions and so on. But in general, all the plants are in the good shape, and I will continue the experiment for the next week. There are some minor marks and scratches on the plant leaves, but I think they were originally there, they were not caused by the radiation. And as an aside note, keeping the object near the radiation source doesn't make it radioactive. As we can see on the radiation detector, the level is fine. And now I will keep the plants for the next week and we will see how it's going. Okay, the second week passed, and with the magic of the video you will see the result right now. First I will show you the setup. This is the first plant that was exposed to the gamma radiation, and nearby there is a second plant that is exposed to the beta radiation. And as an aside note, I can show my radon detector, and as we can see it shows that the values are good. A bit later I will show you my upgrade, and it will cause some radon issues, but for now it looks fine. And now let's see the plants. So as a reminder, both plants are exposed to the beta and gamma radiation with the level of about 100-150 times more than the background. The daily dose obtained by the plant is roughly equivalent to 3-4 chest X-rays per day. And both plants are growing in this condition for about 2 weeks. So how are they actually growing? And as we can see, the result is surprisingly good. This is the first plant that was exposed to gamma, and visually I don't see any critical problems with it. I can also repeat that irradiating the object does not make it itself radioactive. As we can see, the level is normal. The second plant, the red one, was exposed to beta, and it was that one that was growing the fastest. And as we can see, it also looks fine. And the third plant, the control group, was not exposed to any radiation, and as we can see, it also looks fine as well. And when the second week was done, on the local online market I saw an interesting object, an aviation compass made by the American company Sperry Gyroscopes. And it was interesting to me for two reasons. First, it was the same company which made the compass I'm using for this test. And second, this radiation compass is bigger and it has a radium paint in the good condition. As an example, on the right you can see a clock with a radium dial, and on the left you can see this compass, and the radiation level is about 3 times higher. And interestingly, this compass glows yellow and not green. So as you can guess, I decided to upgrade my setup and to prolong the experiment for 1 week more. Okay, another week passed and I will show the results. As a reminder, the first plant was radiated with gamma, and the second plant was radiated to beta, and the third plant didn't get any radiation at all. And by the way, I replaced the vintage clock with the aviation compass. Did it really increase the radiation level? Actually not that much, because the highest radiation is only on the surface. This plant is not really big, but already within 10 centimeters the radiation level is really lower. This is practically the inverse square law in action. This is the picture of the setup, and as we can see, the radiation level is higher, but it was not drastically higher. The radiation level strongly varies from the position, and I can roughly estimate that it is maybe about 200 times more than the background. And I also must repeat that already within 20-30 centimeters the radiation level is normal, so there is no danger. There was only one important difference that is interesting to see. I replaced the vintage clock with the compass, which has more radium paint inside, and a week later I can see that the radium level is higher. However, I don't know if it was caused by the compass itself or is it just a natural fluctuation. Anyway, I adjusted the window ventilation and the problem was solved. But you should keep in mind, if you have similar objects like this, that it is a good idea to have a radium detector. And now let's see the plants. And as we can see, the results are interesting, and honestly I did not expect them. First, all the plants survived the experiment without any visible damage. As we can see, all three plants look good. And even more, the first two plants were growing faster than the third one, however, maybe just a coincidence. And now let's understand why it happened, why I see no damage. You can see the calculation dose on the screen. As a reminder, the first plant was getting 18 microsieverts per hour within first 2 weeks and about 25 microsieverts per hour in the third week, which is in total about 10,000 microsieverts or 10 millisieverts, the result you can see on the screen. The second plant was getting a dose of 12 microsieverts per hour within all 3 weeks, which is in total about 8,000 microsieverts or about 8 millisieverts. Now let's answer the question, is this value actually big? And the result is interesting. From the common sense perspective, the radiation level of 200 times more than the background sounds scary, right? However, we can open the Environment Protection Agency website again, and we can see that this dose is legally allowed for the radiation workers. The annual limit is about 50 millisieverts. So technically, getting the 10 millisieverts radiation dose is legally allowed not only for plants but also for humans. I'm not working on a nuclear plant and I actually don't know how often it happens. If you know, please write in the comments below. But as we can see from the official government limits, these values are not critically high. And also the plant biology may be simpler compared to the human body. So technically it is not surprising that the plant did not get any visible damage. And by the way, just a fun fact, at the time of doing this video, American astronauts were traveling to the moon, and during their travel they crossed the so-called Van Allen radiation belts, and in this area they also passed the zones of the high radiation. And as we know, all 4 astronauts returned back safely to the Earth. So as for the plant, I was initially expected that they will be damaged, but when I calculated the final dose, it turned out that it's not critically high, and technically it is not surprising that the plants survived. 3 weeks later, when this experiment is done, I can ask viewers, does it make sense to make the second one? Generally, it makes sense to prolong this experiment for a year, because as we can see, 3 weeks is not enough to get the significant dose. And as for the experiment itself, I have 3 ideas. First, I can put the aviation compass near this plant for a year. Second, I can put a small piece of the uranium ore inside the plant spot. And third, I can keep the uranium-glazed jar near the plant. Would you be interested to see the results? Write in the comments below. And also don't forget to press like and subscribe if you want to see what's going on. And that is it for this video. Thanks for watching. I hope you learned something new. Press like and subscribe if you want to see more videos like these. Also, if you have more ideas about the next experiment, feel free to write in the comments below. You are also welcome to visit my Patreon page. This support helps me to buy stuff like this for testing. Thanks for watching and see you next time.